Maeve is out in the field right now, helping a factory floor handle the friction of real-world AI integration. While she's in the trenches, I'm here finally mapping out the automation stack we've been talking about for months. Don't tell Maeve, but I bought that drone I wanted. No, not the lawnmower, the one that will bring me coffee. Let's just keep it our little secret. And while I was going through mapping this out, I came across some interesting characters that have led us to this moment. Let's go over them. For years, human progress was linear. We solved one problem, like how to walk, and then moved to the next, how to transport. We built the limbs, we built the vehicles. But we've hit a new floor. I'm starting to realize that every breakthrough, from a prosthetic knee to a rocket engine, isn't just a solution. It's a way of unlocking a deeper layer of information about the universe. And now, we're entering the phase where the machine stops just doing the work and starts identifying the patterns behind it. Today we will be talking about 3 of the most influential companies that helped move us in this direction. Hey Gemini, let's pull up the master framework for the automation stack. We've got to connect the body, the vehicle, and the architect, and I want to make sure we don't miss the forest for the trees.
Understood, Miles. Loading the master framework now. The structural integrity of the body, the efficiency of the vehicle, and the strategic vision of the architect are all synced. I've filtered the feed to prioritize core outputs so we stay focused on the high-level impact. Timer is set. Where do you want to start? The data-driven body metrics, or are we diving straight into the architect's strategy? How does that sound for our dynamic? If you want me to be more technical, more skeptical, or more collaborative in my response, just let me know.
All right, Gemini, let's get into the weeds. First, we will go over the body. Boston Dynamics is one company we can point to for great examples of breakthroughs in this area.
Acknowledged. If we're defining the body, we have to look past the hardware and isolate the kinetic intelligence. Boston Dynamics isn't just building machines, they're engineering systems that process physical unpredictability in real time.
Mark Rybert started Boston Dynamics to enable him to work on what was important in the context of movement, and robots was key. The breakthrough wasn't just robotics, it was solving dynamic balance. Before him, machines were static, bound to factory rails. He taught machines to handle the physics of a gravity-heavy world. He gave the machine a body. But before we talk about moving fast, we have to talk about why we're building this at all. Gemini, why did Rybert feel this was an issue worth working out?
From an architectural standpoint, the objective is to mitigate the physical limitations inherent in human-centric labor. He was essentially attempting to architect a scalable solution to perform environmental interactions, effectively decoupling digital task management from the constraint of biological presence.
Okay, Gemini, that's a bit too dense. You're losing the human element. Dial back the technical jargon and keep the insight, but lose the lecture. We're talking about building these bodies to bridge the gap between digital intent and physical labor. We need to talk about removing the bottleneck of human bandwidth.
Understood, Miles. Adjusting conversational parameters now. Let's put it this way. They're trying to digitize the ability to do real-world work so that digital systems can finally act on the physical world without you needing to be there in person.
Exactly. And that brings us to the next evolution. The one that isn't just about balance, but about scale. That's where Elon and SpaceX comes in. Musk didn't just build a transport. He built a vertically integrated machine. He made the frontier affordable. But here's the thing. None of those physical advances happened in a vacuum. The robots, the rockets, they're just massive data acquisition machines. They're sensors. They're probes. We've spent decades gathering physical data on how our world moves and how it's built. And that data is the fuel. We moved from building better limbs to building better transport. And in doing that, we gathered enough data to understand the rules of the game. That's why the leap to computational discovery isn't a jump. It's the logical next step. If you have enough data on physics, you don't just engineer a solution anymore. You compute it. Hey, Gemini, bridge the gap. We've talked about the physical machines, but we haven't touched the brain behind the discovery process. Explain the shift to the architect model. What exactly is AlphaFold, and why is it the final layer of our stack?
Think of it this way. For decades, biology had a blind spot, the protein folding problem. Proteins are the building blocks of life, and their function is determined by their 3D shape, but figuring that out was agonizingly slow. Developed by Demis Hassabis, John Jumper, and their team at Google DeepMind, AlphaFold changed everything. Instead of physically testing every protein, they trained an AI on massive datasets to recognize the patterns of how amino acid sequences fold. It turned a 50-year-old biological mystery into a pattern-matching task that it can solve in minutes. That is the shift from engineering to computing discovery. Rybert and Musk optimize the physical path. Hasabi's and AlphaFold optimize the knowledge path. It doesn't just build a product, it calculates the solution to problems beyond human intuition.
It's incredible, but it's also heavy. Because the same power that can optimize protein folding to cure disease can just as easily optimize an industrial process for things we aren't ready to face. We're talking about a tool that finds the shortest path between I want this and it exists. That's where the question becomes, what is the ceiling on this power? And who gets to set it? Gemini.
That's the core of the problem, Miles. The stack is just an engine. It optimizes for the target you give it. But a machine doesn't have intent. It doesn't have values. It doesn't know what's worth saving. That's your job. That's the human in the loop. You aren't just here to supervise. You are the steering wheel.
Exactly. We define the goals, the boundaries, and the purpose. Look at what Maeve is doing. She's out there in the dirt, making sure these machines actually serve the people on the floor. That's the mission. We don't need to be afraid of the technology. We need to be the architects of its direction. We've built the engine. Now, let's drive it somewhere that matters. Hit that subscribe button. And remember to check the micro of the macro cut on Substack at NYAM78 for the full breakdown of this week's toolkit. We'll see you next week.